Proportions, which you've all done, which is not new at all for any of you. The only thing that's going to be a little bit new today is this little thing called the geometric mean, and it's actually really easy. Geometric mean is going to help us a lot more second semester. It's just kind of an introduction of what it is today, and it's basically a couple of buttons to press on your calculator. Right. Speaking of, you got to have a multi-view calculator, one that simplifies your radicals. We're going to talk about that again here in a minute too. Plus ones that work with fractions, because that one has a button that simplifies fractions automatically for you, which is also extremely helpful. Ratios. As you know, ratios is nothing more than a comparison of two things by division. Bless you. And when we talk about by division, usually means it's just written up as a fraction. You guys have all seen the different ways they write it out. You can write it as fractions. Let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 1, 2, 3, 4. There's 24 girls to 1, 2, 3, 4, 5, 6, 7, 8, 9. To 9 guys in this classroom. The ratio of girls to guys is 24 to 9. But what do you always do with fractions? You simplify. What are those both divisible by? 3. So that equals 8 over 3. So the ratios of girls to guys is 8 to 3.
One of them's you.
I know. And then and that's skipping out 2 other girls too that aren't here. Start thinking about that. So you can see it, they're written as fractions. 8 to 3, I'm sure you've seen that before. And also the other one is the colon, yeah. 8 to 3. First number is always the one that goes in the numerator, second one's in the denominator. I realized, I knew it was lopsided, but I didn't realize there was that many more girls than guys in here. Crazy. What do you always do with fractions? You simplify. You guys know how to simplify a fraction in the multi-view calculator? How? That one won't do it. You need to get that button. You got to get these calculators. Just for fun's sake. Once it loads. Try this again. Oh, I hate how, oh well, whatever. It'll load up eventually. Basically, it's a matter of pressing the buttons in the calculator. Guys, there's a fraction bar. Use it. There's no such thing as a mixed number. There is really no place for them to be used anymore. I could probably count on one hand the amount of times that you will use a mixed number after geometry. We use it maybe one time in Algebra 2, bless you, and there's, bless you, third time's a charm. And usually there's maybe one other time in pre-calc that you'll use a mixed number. They're not easy to work with. It's much easier to always use the improper fraction, the top heavy stuff. So what happens then is that you get ratios like we just did. What was it, 24 to 9? And when you simplify it, you create what's called a proportion. Proportions are ratios that are equal to each other. Proportions are just ratios that equal each other. That's it. Real easy way to tell that that works is if you think about the way that you simplify fractions. 4 over 8, 1/2, things like that. But the way you check to see that it works, oops, is that you cross multiply. Okay. Whenever it is a proportion, it's going to be written as a fraction equals some other fraction. If it's a proportion that is true, then that means that 9 times 8 has to equal 3 times 24. Well, that's 72, and lo and behold, that's 72 as well. That means we know that we simplified our fraction correctly because when you multiplied it out, it equaled the same. Okay? There are other terms for the way you cross multiply, but we don't even bother with that anymore. They're called means and extremes. To be honest with you, I forget which one's which, but that's okay. I know that all of you guys have worked with this before, and this is nothing crazy or anything new. What we do work with these, though, is that we do try to simplify the ratios. And like I said, it's just a matter of having your calculators to do that. For example, is that a word? If I wanted to simplify either one of those, I'm going to simplify 60 miles over 51 miles. Are they the same unit?
Yes.
Yeah, that's the one thing you just have to be careful of. You have to be careful of the same units. And we have 3 calculators open. And like we did earlier, create the fraction bar. You guys, your buttons are easier to find than mine. 60 over 51 and hit enter and dun dun dun. It gives you an answer. It tells you what the ratio simplifies to be. So hopefully you don't press the wrong button. That's really all you have to do with some of this. And over D. Fraction button is this right here. It's next to the natural log, the ln. Ladies, come on. Next to the ln, it's the second one over from the left, third one down. Centimeters and millimeters, are those the same units? Do you know what the trick is for when you have different units of measure and you have to simplify? Work with the smaller unit. Always work with the smaller unit. So you have to figure out now which one's smaller, a centimeter or a millimeter? Millimeter. You know how to convert millimeters to centimeters? Okay. Multiply the centimeters by. Okay. Really, the only things that I'm going to keep you guys accountable for is how many inches are in a feet, in a foot. How many inches are in a foot? 12 inches in 1 foot. How many feet are in a yard? 3 feet, 1 yard. How many feet are in a mile? 5,280 feet in a mile. Yeah, yardage, right? But it's meters, so. Wait, no, that's right. Yep, I forgot. For some reason, I was thinking outdoor stuff. So, and really the only thing. Yeah, no. The only thing I know about the difference between meters and yards and feet is that 100 meters is usually about 3 seconds slower than 100 yards. Because it's longer. You guys all don't care. So here what I would do when you go to simplify stuff out, obviously you have to just multiply the centimeters by 10, so you get 70 over 14. The reason why we always want to go to the smaller unit is because that way you don't have to worry about other decimals or anything. Yeah, to go from centimeters to meters, yeah. And then you just put it in the calculator, and it gives you an answer.
Is that what you do when you have millimeters? Then you'll times it by 10 to get into centimeters?
Yeah, well, if you have millimeters to centimeters, you would divide by 10. But that's why I'm saying if we multiply by 10, we don't have to deal with the extra decimals and stuff.
Okay.
That's why you always want to work down to the smaller unit. It's easier to work with then. But like I said, more often than not, I'm going to give you feet, inches, yards, and things like that, okay? Now the weird stuff comes in then when we talk about triangles. Now the goofiness for ratio things are going to come in terms of finding angle measures, and in a couple minutes I'm going to show you guys how we work with side lengths. Now there's a couple things you know for certain when you have a triangle. First thing you know for certain is that you have 3 angles. Triangle. Get it? Anyway, you also know what all 3 of those angles have to add up to equal. How much? 180. So what happens here is that you have 3 angles that have some ratio of 5, 9, and 16. That means that there's got to be some common multiplier that all 3 of these have. Which means if I add those 3 together, what should you equal? 180. So all this is this. And it turns it into a 2-step equation. Whenever you're given a ratio for angles, you put an x next to the numbers and you add it up to equal 180. That's it. You can try to make it more difficult for you, but I think that's pretty straightforward. So now the tough part. 5 plus 9 plus 16.
Oh, I don't know, man, maybe 30.
Whew, it's tough. And what's 180 divided by 30? 6. Which means that your angles had a common value of x of 6. They were just multiplied by different value. One was multiplied by 5, 9, and 16. So to find your angle measures, well, just substitute back in, 5 times 6, 9 times 6, and 16 times 6. 30, 54, and 96. Like I said, we can try to make this more difficult for you, but it is pretty darn straightforward. Okay. So remember, whenever you're dealing with an angle, you're dealing with the angles of a triangle. They add up to 180, you put an x next to it each time. It doesn't change. Now the difference between this and say perimeter. Perimeter, do you know what your angles are? No. Are you dealing with angles when you're dealing with perimeter? No. So in that case, you can have something that looks like, oh, I don't have it open, we're going to restart the computer. Let me open this real quick. They have something. Perimeter of a rectangle is 50. The sides have a ratio of 3 to 2. The perimeter of a rectangle is 50. The sides have a ratio of 3 to 2. Well, when you're dealing with the perimeter of a rectangle, do you remember how to, well, first of all, how do you find the perimeter? you add the sides up, right? So you get lengths and widths. How many widths are there? How many lengths are there? Are they the same width, same length? Yeah. So one of the ways that we wrote up how to find perimeters of rectangles was always this formula. Perimeter was twice the length is twice the width. Okay? That's not new, right? Pretty sure we've all done that. Well, in this case, it's telling us the ratios of the sides is 3 times some multiplier, and the other one is 2 times some multiplier. So what do you think I'm going to put in for length and width? 2x and 3x. So what we do is we fill in the blanks. 50 is twice the 3x plus twice the 2x. It's similar to what we did with the angles, but just a little different. So the real tough part now. 2 times 3 plus 2 times 2. Good luck. Think you can do it? I hope. What's wrong? Are you you're like conscious? You're a little conscious on that one?
No, we just looked at it.
Sorry, just looking around to everybody. Did you think you were gonna get that one wrong? Well, what's 2 times 3 plus 2 times 2?
I don't want to answer it.
Why not?
Because.
All right, let's start over. What's 2 times 3? What's 2 times 2? What's 6 plus 4? You sure? I'm just messing with you.
X equals 5.
So what's 5 then? Or sorry, what's x?
5.
5, yeah. So 5 is x. But if I wanted to figure out what my side lengths are, there's the common multiplier. I substitute back up, I get 10 and 15. Like I said, it's not anything really crazy. It's just a matter of knowing what you've done in the past as far as how to find perimeters and stuff. Okay? It's very, very, very straightforward. Let's try another one. If I have a perimeter of 36 and a ratio of sides is 8 to 1. Hi. If I have a ratio of sides, it's 8 to 1. Yeah, they don't want to mess. They don't mess with it too much. They really don't. Because if it was a square, wouldn't the ratios just be 1 to 1? Because they're all the same, no matter what. So again, it's just twice the length plus twice the width is 36. Remember, if they're giving you the ratio of 8 to 1, that's your 8 times the multiplier and 1 times the multiplier. That multiplier is always the same, so we just call it x. If you double 8, what do you get? If you double 1, what do you get? What's your value of x? It's 2. If 2 is my value of x, what are my sides? This one's 8 times something, this is 1 times something. So it's 16 and 2. Not drawn to scale. Yes, ma'am. It doesn't. It tells you length to width. But if you start thinking about it, it doesn't matter which one's which in a rectangle. Basically, put an X next to it and double it. This is where we're going to get towards. Ratios of side lengths of similar, what are called similar figures. We don't use it a lot right off the bat here, but if things have the same ratios, if figures have the same ratios, we can set up what's called a similarity statement. It's just like a congruency statement, but instead of being equal, they're going to have equal ratios. Okay. So if I'm looking at two triangles, ABC and DEF, which triangle is written down first? ABC. So what triangle do you think I would put all the values in the numerator? ABC, because it came first. The numerator is the first part, the denominator is the second part. How many sides do triangles have? 3 of them. If it's triangle ABC, I have sides of AB, BC, and AC. You okay with that? And then if I have triangles DEF, the corresponding letters, like we've done before, still works. But it creates these 3 fractions, which are ratios. If they all have the same ratio, which they will, it means they are proportional. That's how this is going to work. We use that setup a ton. And again, it just stems from the state that you're given and writing out fractions. Then all we would do later on is just fill in the blanks. Because if you know that you have a certain ratio, or if you know that you have similar figures, you can find missing side lengths by just working with the ratios. How all the different corresponding parts work, things like that. This isn't super important today, but going forward, it becomes really, really important. We do a ton of it. Okay. Question on that at all? That's pretty easy, right? 1/1000.
If you say a moment, then he has to wait for 90 seconds.
Is a moment 90 seconds? Oh, more than that. Isn't every moment just something part of time? Is it captured that intensity by time? Aren't we in the moment right now? Has that moment passed? You sure? Isn't every moment passed? Along with every moment. That was a moment. Which means you're going to be doing this over and over and over again. That's a horrible moment if you're So what happens, guys, we're going to have a ton of cross-multiplying solves. This entire chapter, ladies and gentlemen, this entire chapter is basically the same math problem over and over again. Fraction equal fraction, cross-multiply and solve. Okay. That's all this stuff winds up being. Go through, 4x is 40, x is 10. This is, you're going to be happy for a while. This last group of problems, this last chapter, is quite often just cross-multiply and solve. Excuse me. Now, you could also do this. What if I didn't do that?
You'd have to distribute.
Is it still fraction equal fraction? Yeah. So 3 over x minus 3 is 6 over 8. So, what do you do? Yeah, same thing. 8 times 3 is 6 times the x minus 3. What are you going to forget to do?
Distribute to the negative.
Yeah, don't forget that, guys. Draw little arrows, do whatever you can to help remind yourself, because that's usually where you guys will mess up. You forget to do both parts. So 24, 6x minus an 18. Yep, add the 18 over, we get 42. Divide it out, we get 7. Okay. Or a keen observer might have noticed, 6 over 8 simplifies to be what fraction? 2 over 4? That's 1/2? It's 3/4, right? Which means what does x have to equal if it's going to equal 4? 7 minus 3 is 4. Pretty shortcut. Okay. Here, do these two. Do these two real quick. A couple algebra problems for you. D. Did you get 8? I probably did it differently than you, but that's fine. Again, 8x is 24x minus whatever. So 24 times 12 is what? Thank you. Moving stuff around, we get 288 is, what is that, 16x? Is that 18?
Yep.
What's that?
How'd you get 288 on the other side?
24 times 12.
No, like on the second. She's trying to say, how did you put 288 on the other side?
Oh, to move it over here?
Yeah, back.
I moved it over, and I subtract that. I did those at the same time. Okay. Now, really the only other thing that's left to talk about, aside that it takes any more than 4 minutes to show, is something called geometric mean. The geometric mean is different than what you guys have done in the past. The geometric mean is what happens when you have two numbers, and the number between them is the same. And here's what it looks like. When you have what's called the geometric mean, the geometric mean is when you take some number, divide it by x. And then that same number, x, when you divide it by something else, that proportion works. Okay? That proportion works. It looks weird, but as you get going into this stuff, it turns out to be pretty easy to work with. For example, if I say that I have 8 and 2, I want to find the geometric mean this is how it'll be written. 8 and 2. I want to find the geometric mean of 8 and 2. Well, I know that I'm given 8 and 2. So I put those opposite one another. What goes on this diagonal in the middle is always that. It's still a cross multiply problem. It's still a cross multiply problem, but what's x times x now? Ah, that's when you add. When you multiply them, it is x squared.
Oh, yeah, that's what I meant.
And then how do you undo squaring? You square root it. So what's the square root of 16? So basically that means that 4 is the geometric mean of 8 and 2. Now if you look at it, what's 8 divided by 4? And what's 4 divided by 2? 2. you get the same, when you simplify it out, it works out. But, will geometric means always work out to be a nice clean number? No, not at all. For example, what happens if you have the geometric mean of 4 and 3? Hi, welcome back. If I went to the geometric mean of 4 and 3, I still start it the same way. 4 over something is something over 3. What's 4 times 3? 12. So I multiply it out, I get x squared is 12. Now it comes into the part of making sure that you know how to use your calculator. Ladies and gentlemen, decimals do not exist. Simplified radical form is what exists. If I take the square root of this, it's going to tell you 2 root 3. Those are exact answers. If your calculator does not spit out 2 root 3, we sell those. They're $15. Exact answers are what we want. Which means you could either do that or remember that how to simplify a radical via primes or by perfect squares. Remember what perfect squares were? 1, 4, 9, 16, so on. 12 is divisible by 4. So that's the same thing as saying the square root of 4 times the square root of 3. What's the square root of 4?
2.
That's why we get 2 root 3. Guys, this exact answer stuff doesn't go away. We use it over and over and over again, basically all second semester. If you don't have one of these calculators yet, we have a case of them in the office. We're still selling them. Please buy one. Take Ezekiel's because he's sleeping through all of it. All right, you gotta have one of those things. It's how decimals don't exist. They do not exist. You guys understand that?
Where do you get checks paid to?
DHS is fine. Let's see which one. About 45 and 5. I do 45 and 5, same deal. You start with 45 over x, x over 5. Multiply that out, you get x squared is it 225, I think? This one works cleanly. This one gives you an exact answer, a numerical answer, a non-decimal answer. 15. Because 45 divided by 15 is 3. 15 divided by 5 is also 3. That's why this works. Okay. We get more involved with geometric means second semester, like I said, with similar right triangles. There's a lot of weirdness that happens with those. I don't need to show you guys how to count a number line, right?
No.
I think you can do it. Do those. Please.
Even.
If this takes you more than 12 minutes, you're doing it wrong.
Okay.
Okay? Seriously, it's a really, really quick assignment. All right?